Hello everyone. In this video, we will introduce generic programming with templates using C++. So what is generic programming? Generic programming is a style of computer programming in which the code is written in terms of generic data types and actual data types will be specified later. So it allows writing code that differ only in set of data types. Let us see one example here. So this is the example of a function which will find maximum of 2. Now there is an integer version, 2 parameters are passed, and depending upon which is the maximum, will either return first one or second one. If you look at this, this is the version for double data type. If you observe both the functions carefully, you will know that the logic of the function is exactly same and they differ only with data type. So templates allow us to write the code in which data type is used as parameters and compiler instantiates the specific version providing the data type as parameter. The advantages of this approach includes code reusability. Also, there is no need to overload the functions manually. So this generic programming is supported in C++ using the concept of templates. Template is blueprint for generating classes and functions. Two keywords are used in C++. Template keyword is used to declare template function or class, and the type name, this keyword is used to denote the generic data type which is used to define the body of class or function. As templates are instantiated at compile time, this is also called as compiler or compile time polymorphism. Let us see the function template. We came across common code like sorting elements, finding maximum, finding minimum, printing array. So in order to declare function template, the syntax is template is the keyword, specify the below function is template function, and type name defines a generic data type, and this data type can be used as a type of parameter, local variables of the function, even that can be used as a return type also. Now how to call the template functions? There are two ways of calling the template functions. First one is implicit, where we call function as normal function and compiler will instantiate template based on data type of parameter. Second method is explicit, in which data type is sent as parameter to the template using angle brackets. So following the function name in angle bracket will make use of data type, so function will be replicated for that particular data type. Similarly, the syntax for a class template is same. Template keyword is used to specify that is template class. Type name is used to denote generic type, and this type is used in the class definition. Now, how to create objects of class template? For that, the syntax is again very simple. Whatever the name of your template class is there, followed by data type in angle brackets, followed by name of the object. So that is the syntax for creating objects of template class. Let us see example of template instantiation for function template. Suppose we have written a template function as shown here to find max. Note that the generic type name t is used as a return type here, as a type for parameters also. And suppose from main function we want to call this template function once for integer and then for a double. When compiler sees that the function template max is used with integer data type, it creates or instantiates a copy of function max for integer data type. Note here that the type t is replaced with integer. So template is instantiated for integer data type. Same thing is done for double when compiler came across max of double. So it will create or instantiate template function for double. So likewise, we can write a generic function which could be used for multiple data types. Now let us see what is template specialization. Though templates are used for generic programming, sometimes we need special behavior for a particular data type, and this is called as template specialization. For example, if we want to implement counting sort for data type character and quick sort for rest of the data types, then as shown here, we write a generic template. This one is a generic sort function used by all the data types except character. So the generic sort function is written with type t, and separate function for character is written there. Remember, the syntax is we need to make use of template keyword followed by empty angle brackets, and sort method for character data type is written like sort followed by name of data type, that is character, in angle bracket. So this is the code to implement sorting method for character, and for rest of the data types this generic sort function will be used. So this is called as template specialization. Templates are not limited to single parameter. We can use multiple data types as parameters. And even we can have default values also for the data type. So in this example, template class A makes use of two parameters denoted by t and u have the default value as a character data type. So the object A will instantiate class A for float and character. Remember, the second data type is missing, so default character will be taken because we mentioned that in the template. Whereas object B will instantiate class A with integer and double. In function template, we can make use of static variables. Here each instance will have its own copy of local static variable. So in this example, even though 3 function calls are there, only 2 instances will be available, as first and second call refers to the same function which is instantiated for integer data type. So the same variable will be utilized by both the calls, so it is incremented. Whereas in third function call, it instantiates another copy as data type is changed to double, so it will have another copy of static variable I, so it prints value 11. Thank you.